So, as Matt said, my name is Danilo. I'm part of the Evangelist team in Amazon Web Services. And I got passionate about serverless when we launched AWS Lambda in 2014. I started to see all the potential. So I wrote this book that has been translated to Chinese and Korean. And I also work with Manning for a free ebook. So if you are interested in an overview of the serverless technologies that can help kickstart a new project, like what is a web API, how can I set up an agile development team. The last one, Agile Development for Serverless Applications, is a free ebook that you can get. And as Matt said, Manning was kind enough to give this discount for everything on their website, and I will tweet it after the session so that you don't need to take pictures. So when I started, most of my talking with developers was how can I create a function, how can I integrate a function. Now I see that we're starting to see developers, they want to use serverless to go to the next level. They want to build more complex applications, maybe use serverless together with traditional architectures, with virtual machines and containers. So most people tell me, I know, it's relatively easy to create a serverless function. What should I do next? So the idea of this session is to see what I think are relevant topics that we should invest some time on. And probably the first one that was actually across most of the sessions today is infrastructure as code. So the first thing that you should take is describe what you want to build in a text file. This makes all changes easy to repeat, and for people that is born in the cloud, probably this is easy, but everybody who works with real servers knows that it was really a pain to replicate things across different environments. And also, you can now use the same release tools that you normally use for source code to update your infrastructure. So this is making, for example, some best practices from software development applicable to infrastructure management, like small deployments, means small changes to your infrastructure. This is much easier to do if you follow this best practice. And you can, of course, replicate what you do in multiple environments much easier. So if you need a stage or a test environment, you can just use the same template to rebuild it. And when we do infrastructure as code, actually there are two different paradigms. Some are based on an imperative syntax. So basically, I tell to my programmable data center what they need to do. So create a virtual machine, install this, do that. This is probably not the best approach. Look for tools that use a declarative syntax. So basically, you ask them what I need. So I need a virtual machine with these characteristics. I need this configuration for my security group and firewall to allow for some network flow. This is much easier because then the infrastructure as code tool will understand what are the priorities, the order of the operations, and will make things much, much easier to replicate. It's similar to programming languages. Now, normal procedural programming languages are imperative, like Python or Java. If you do a SQL select, this is declarative because you tell to the database, I want to select these things, and then it's the database engine that will decide which table to look and start for extracting your data. Also, there are some programming languages that are declarative, like Prolog, for example. It's a programming language where you tell, demonstrate this thesis, and the Prolog engine will find, based on the data, the best way to find a demonstration or not of what you ask them. So when you have an infrastructure as code platform, you can tie in the same software repository this application code and the infrastructure code, and you can use the same tool to deploy at the same time the infrastructure change and the application change. So this is a very, very good practice, also for testability. And sample of these platforms are HashiCorp, Terraform, and on AWS CloudFormation. What does it mean for serverless? For serverless, we don't create, by definition, servers directly, but we want to coordinate the configuration and the creation of higher order components like Lambda functions or database tables or object storage like Amazon S3. And this is something that it's not easy to do with the traditional platform. That's why there are specific tools that are started in this place. So, for example, the serverless framework has been nominated lots of times today. It's a great tool. And also in AWS, we created a subset of CloudFormation. It's an open source project because we don't want the serverless community to reinvent the wheel. It's called the Serverless Application Model, and it is a very simple way to describe serverless applications. This is an example of a template with 20 lines of code. We declare that we want a serverless function. This is the role that, the permission that we want to give to this function. And by the way, if you start using SAM some time ago, more than 1 year ago, this is something that we improved a lot. So now we have what we call policy templates, like this one, where you have policies with variables. So you can say, I want to give read policy to a DynamoDB table, and this is the table that I want to reference in my policy. So have a look, because probably you can improve or simplify the configuration of your permissions with these new policy templates. Then with the event, we can create an API gateway for my function and a DynamoDB table that I have read-only access. So since this is created now as empty, probably this is not a super useful function. We also worked a lot with tooling. We created SAM Local a couple of years ago, then we started again from scratch with SAM CLI, getting feedback from the community. This is now a quite powerful tool. You can, for example, tail the logs of functions that are executed in the cloud directly on your laptop, and do things like tailing and doing grep on logs. Something that I enjoyed with traditional application, and I like to do that with serverless again. More recently, we added the possibility to build, and Slobodan, who was speaking here, they also contributed together with Goiko the npm build engine to the SAM CLI build command. We also, even more recently, added the publish command. And you can publish a serverless application to a serverless repository, application repository that you can use to share privately or publicly your applications with other developers. And this is quite interesting, because when you start to share not a single function but a whole application, you can create composable applications. So this is a very simple use case. So lots of customers, they want to monitor social media. And if something happens in social media, they want to do something custom. Maybe they want to send an email to someone, or they want to store the information or process the information with sentiment analysis and then take an action out of the result. So there's a mix of common problems and specific custom requirements. So with the serverless repo, now you can take the standard component, that is the polling Twitter using the standard API, searching for something that is specific to the keywords that you're looking for, and the custom business logic that is the action that you want to take if something is found on Twitter for your social media requirement. And this is something that now you can put in a SAM template. So this is an example of a template where you say this template is using a whole application that is a nested application that has a specific ID in the repo, a specific version. And the options of this application are the keywords to search on Twitter, so the search text, and the function that maybe is created in the same template that is invoked in case something has been found on Twitter. So we are really with, in this case, 9 lines of code integrating another application inside my application that at this point needs only a single Lambda function. We also are exploring other ways, because infrastructure as code, and for me, JSON and YAML is not really code. One of the problems that we see is that if you want to replicate something, for example, you want to create some virtual networking configuration that is a standard for your company, and you want to replicate this networking configuration like a VPC across different applications, it's a lot of cut and paste. And it's probably not the best way to work. So we are exploring this with the Cloud Development Kit. This is another open source project where you can use languages, normally strongly typed languages, because they get an advantage here, like TypeScript, Java, or C#. Those are the ones that we support right now. And you can really start to use your standard programming language to assemble components like networking, virtual machines, serverless components, and create a higher level component that then you can share as an entity in your programming language, like a new class in Java that I can share, and it's my configured VPC. So it's really interesting. The fact that you have a strongly typed language helps you mix the right components together. And this works together with a construct library And there's a specific construct library that is built on top of SAM. So basically what means that you can use TypeScript or Java or C# to take SAM components, assemble them together, and release a new component that you can reuse in other projects. This is in developer preview, so that means that it's not production ready, but it's also the good time if you want to give your feedback and tell us if you are going in the right direction. So after infrastructure as code, what I see is really important is managing deployments in the best way. This is something that in the past was not critical. Now the whole pipeline, starting with the source management, the build and packaging of your application, and then the automatic testing and deployment in production is really critical. Here, there are normally two different schools. Now, sometimes people, they only want to do continuous integration so that they automate the build to see that they don't break the build. But I strongly suggest you to investigate continuous deployment. That means automatic deployment, probably after an automatic test in production. So this for serverless means that normally you have the template describing the functions, the buckets, the database tables that you need, and your application custom code. This is packaged together, and then the serverless platform can deploy this and implement this in a stack, like with CloudFormation. Probably you want to go through different environments, so you can have a test stack where you run your automated test, and then you can deploy if everything is okay in your production stack. And here you can get the feedback, because the important part of this continuous deployment is that it makes it much faster to get a feedback when you create something new for your customers. And the speed at which you get the feedback from your customer is basically the speed at which you can develop your application. If it takes double the time, you will be double slower to create anything new for your application. When you start being in production, the feedback loop is really critical to follow and understand if your customers are using functions that they are not only technically correct, but they also are going in the right direction. And we think continuous deployment and features like canary deployment should be part of the features that a serverless platform gives. So we integrated canary and linear deployments with Lambda using CodeDeploy, our deployment tool. And it's also integrated in SAM if you want. So you can add just a line saying, I want to deploy this function using canary 10%, 10 minutes. And that means that if you have a version 1 of your function and you start deploying a new version of your function, we can run a function that we call pre-traffic that can do some check before we start the deployment. So for example, this pre-traffic function can run your automated test, can be a second level of automated test that you run in production to see that everything works with a few test cases. Then if it works, we start doing the deployment. So in this case, 10% of the users for 10 minutes. So 10% of the invocation of the function for 10 minutes will go to the new version. And you can monitor this with alarms. So if you get an alarm, you can roll back automatically. And then if everything works, no alarms, we can execute a post-traffic function and then open the new version to everybody. The post-traffic function can sometimes, for example, solve the usual problem of continuous integration and continuous deployment, because if you commit some code, this will go in production, but if it fails and there is a rollback, someone has to tell back that this code actually didn't work. So for example, you can use the post-traffic function to tag the commit in your Git repo saying, okay, this is actually in production in this environment. This is quite simple to do, and it's something that I strongly suggest you to implement. We also have some features similar in the API gateway, where you can create, on top of the traditional production stage, a canary stage, and say, okay, send, for example, 0.5% of the API call to a different group of functions. So the main difference here is that it's not working for a single function here, but you can have lots of different new version of functions for a completely updated version of your API, and just send a little bit of the invocation to the second version of the code of those functions. This can also stay alive for a long time, so you can use this also for A/B testing. So for example, for 1 day, I test the new version of my search engine, and then I compare if customer actually are using this new version of my search engine in a good way or in a bad way. So it's relatively very easy to use. We also realized over time that when we talk about functions, like Lambda functions, most of the time there is a thin layer of custom business logic, and this is probably the most precious part of the functions. And then, and this is usually using a few kilobytes of the function space, and then most of the time you have lots of libraries and dependencies. So I'm not entering into the loophole of how to manage dependencies, because that's a big problem, I think, for lots of platforms today. But to simplify this, we introduced the concept of layers with Lambda, where you can group your code, your libraries together, and then share those layers across multiple functions. And the main advantage for deployments here is that you separate things that change with your business, so probably with a fast pace, with the function code, and the layers that probably change with a slower pace, and also whose change is probably driven by the library updates, so it's not something that you control directly. And it's also making deployment faster, because if you have a 50 megabyte function that you need to redeploy and you need to upload 50 megabyte, okay, 50 megabyte is not that much, but it's still some time. Here you just re-upload maybe the function code, and preserve the layer, so it's really like a few kilobytes of upload. So it can help you iterate faster and faster. Code reviews is another interesting perspective for serverless, because, as I said before, most of the times you are actually deploying your infrastructure and your application code together. So that means that your code review must cover also infrastructural change, understand the impact in the architecture. If you change your infrastructure, you create a new function, you create a new bucket, a new table. And what you need to really check for your code reviews is the speed at which you can exchange feedback and you can review the history of your code. Most of the time, code reviews nowadays are done using pull requests. This is perfectly okay, but you need really to understand, do I need to stop an automatic deployment for a code review? So my suggestion is do automatic deployment and eventually use code reviews offline to get a different perspective from maybe another team on what you're doing. So don't use it inside the team like a pull request normally, but unless you have a very large team or you're managing an open source project. But for a traditional small team organization, look for a different perspectives from other teams. It is more useful than a blocking pull request. So after deployment, I think the next important thing to consider is how to manage the whole project. And here, I think, try to shift your management from project to product. So projects force us to think in milestones. So there's version 1 in production, I'm working to release version 2, and by the end of the year, I have to release version 3 because it's including all the requirements. Each version probably includes a broad set of requirements. Products, they are evolved differently. Products, they try to follow the customer needs, so they try things, roll back things, follow and change route if that makes sense, and the customer needs, normally they change over time, because when you release a feature, customers start to say, oh, I like this feature, but I also would like it to do something different here. So it's a completely different way of thinking about releases. So projects force you to think in milestones. You think there is a milestone, and the next milestone is where I have to be concerned about. Products, they really look for creating customer value continuously, every day. So that means that with project, normally the focus is in the cost, in terms of resources and any internal cost to reach a milestone. So it's very common to say, oh, to go to version 2, it took us 2 years and billions of money. With products, you really think more of the life cycle cost of the product. So if you release an airplane, you have to think that this airplane must fly for maybe 30 years. So how manageable is it? How observable is it? How can I help a customer easily from my support team if something breaks, so that I can observe and understand the broken component of this airplane? We should bring the same thinking into software products. In fact, projects, they bring you to look back. No? Projects brings you to look, oh, for the last release, I had to do crazy things, and it costed a lot of money. Products are always forward-looking. What's the next thing that I should do for my customers? And that's also an idea that we shared. So this is taken from the shareholder letter from Jeff Bezos to the Amazon.com shareholder a few years ago. Sometimes it's very easy that the process itself becomes a proxy for the result. No? So instead of thinking with project, you think of reaching the milestone, not of the customer, the value that you're creating for your customer. So this is an example of that. Another problem with process is customer support. You think more of what to do if a customer calls than to actually what you can do to solve the problem of the customer in the fastest possible way. So if you see that sometimes you create processes that are more important than the result of the process itself, something is wrong. And the feedback that we saw before must go through the business for the reason that I said before, because you always need to change direction and adjust based on the feedback that you get. So normally when a product is developed and is adding new feature, there are 4 main reasons why we add something to a software product or a product in general. We want to add new features. We want to resolve some defects. We want to reduce risks. For example, maybe security risk, or we are undergoing some plan for security. And we want to reduce debts, like technical debts. And all these 4 main categories, they get feedbacks from different teams, because the business is driving the features. Customers, they tell us what are the defects. Security and compliance teams, they look for risks normally. And developers and architects think about reducing technical debt so that it's easier to evolve the product. Normally, you should invest time so that customers provide also feedback to the business so that you always know how to evolve the new features, not based on someone that has to release new features because it's the product manager and has a roadmap in his mind, but because really you have specific customer requests that drive the new features. And you should, since there's all this interaction, you should avoid overutilization. So if you have a team of people that is working for a product and they are fully committed for the next 6 months, that will never work because there will be unplanned work. So you should probably reserve at least 20, if not 30% of the time of the people to work on unplanned items. This is really important. Next step is microservices. So this is another topic that came around today a lot. So microservices is super broad. I only want to say that the idea of microservices, I think, comes not from a trend or something like in programming. I think it really comes down to the laws of nature. Complexity is a science that has been developed across the last 20 years, across physics, mathematics, biology, social science. And they found the same behavior across all these different fields. So things become complex, so it's difficult to predict their behavior when there are a lot of dependencies across the components. So this is the same reason why we can't predict the weather in 1 month, because there's so many interactions that it's impossible to know everything with enough precision. And this is the same problem why monolithic applications often become complex to evolve, because internally you have a single code base, you start to cut loose and connect things that were not meant to be connected together, to reuse things that were not meant to be used in that way. And it's inevitable that the entropy will arise and the source code will be more difficult to evolve. That's why microservices are important, because help you create boundaries that are normally business-driven, not technologically driven. And it's the old divide and impera from the Latin word that is applied to software development. So since we have these small services, a very important part of development means how I make these services talk to each other. So there are normally 3 main patterns here. So the message queue pattern, if you have 2 services where you have a single direction of communication where you send data and the other service is processing that data, building a message queue can help you really decouple the 2 services so that if there is different speeds or different requirements, or if one service must be stopped for some times, you can still work without affecting the other. If you react to some event, think of the pub/sub or topic pattern. So the idea is that you create a topic where you can publish information, like I have a new order, I have to be processed, and then all the subscriber will react to this event. And if you think in this way, in a broad way, you can also reuse components easily. So when someone tells you, well, we need to write this component, instead of writing this component and embedding this in a hard way, try to think, okay, I create a component, but every time there is this event, this will be triggered, and maybe I can make this component available for different use cases. Final step is workflows. So when you need to coordinate different components with, especially if you have a distributed state that needs to be kept in sync, think about step functions or tools like that, because they can really help you manage workflow, and we will see that with a customer shortly. Correlation IDs, they're really important. If you have a distributed architecture and serverless is by default distributed, add a correlation ID so that each invocation across multiple services can be traced together. And think also of tracing tools that can really help you map visually what is happening with your architectures. And when we talk about latency, this is how we manage latency in AWS and in Amazon in general. We don't think latency is an absolute value, but use percentiles. So for example, this is an example of the latency of an API. Percentiles tells you which is the value below which you have a certain percentage of observation among all your complete observations. So for example, P50 means that 50% of the latency that I observe falls below this value that is probably 0.4 seconds. P90, 90% of the observation fall below 1 second. P99, 99% of the observation fall below 5 seconds. And P100, that's basically the maximum value I observe, is probably 23, 24 seconds. So this is the way to think, and this is the way to plan for your latency and your latency requirements. And think also event-driven. So there's lots of things here. This could be a completely different presentation, but the idea is if you build an application and you're interacting with storage and databases, think how you can link your business logic to events from this storage and these databases. Don't put all your logic in the first invocation of the backend. So this is a media sharing application. You load a picture. This is written in a storage. This triggers the function that will analyze the picture, build the thumbnails, maybe store the metadata in a database, and update the catalog. So this is a way to think differently, and it's much more scalable at scale. And there are, as a next idea, this is a concept that I think is quite interesting. This comes from economy, not IT, but it's the idea of anti-fragility. So if you think of very complex things, like our immune system doesn't like to be left alone. So if you live a completely sealed environment and then you get out, you get immediately healed. You need to be constantly attacked, and then you can learn how to react and be more resilient. So it's not easy to bring this concept to IT architecture, but I think we're starting to do that with chaos engineering. So the idea of continuously try to inject failure to have an infrastructure that can react when the real failure will happen. So this is a quite interesting concept. Team structure. So how can you build a team structure? Well, normally when we think of a team, we want to solve a complex problem that cannot be solved by a single person. And there are actually two types of tasks. There are separable tasks where I can just separate the task among everybody. So let's say I have 1,000 things to do and everybody is doing a subset of those. And there are non-separable tasks, complex tasks, like creating IT systems. It's not easy to split a complex system into completely separated components. So how can we improve the solution of a complex task? So let's try to build a model of how cognitive tools work. So someone said all models are wrong, but some are useful. So let's see if this is one of those. So let's say that we take people that has different cognitive tools, no? And let's give a letter to each cognitive tool. So for example, Adam has 5 abilities that we call A, B, C, D, E. And let's say that A stands for mobile development on iOS. It's also good with backend development in Java, some data analytics in Python, complex SQL queries, and something else. So let's imagine that it would be so simple to give a single item for each knowledge that we have. If we have 3 people with different abilities, how can we create the best team here? So the normal answer here is, okay, we have Adam has 5 abilities, Betsy has 4, and Carl has 3. Let's take the top 2, and I have the best team. Unfortunately, the best team here has an overlap because they almost have the same abilities. If we look at the letter, they're almost the same. So the overall abilities, different cognitive tools that they have, is 6. If we take the 2 worst people that have less of an overlap, so there is much more diversity there, we can cover different arguments, because probably I have someone from the front end, someone from the back end, someone that is looking at other things. So this is what we call normally the diversity bonus. If there is no diversity, there is no bonus. And this is a problem, for example, when the hiring manager is hiring people that look like him. He creates a team that is the same knowledge as him. And then you can't grow beyond the ability of the hiring manager. Or in some fields where things must be learned sequentially, there is a problem because, for example, if I want to create a team of people looking after convolutional neural networks in machine learning, then probably I need to learn machine learning, then neural networks, then the specific type of neural networks, and all those things can only be learned sequentially. In those environments, you need to think out of the box and find different skills, because otherwise you always look at the problem from the same direction. And this is also something that has been studied in different fields. And this is an NSX study. It's published online. It's from 15 years ago. They studied 2,000 people working in musicals in Broadway in 40 years, roughly. And they studied how these people were working together, how commonly people were working together. And the idea is, this is normally called small world networks in literature. And the idea is, okay, probably people that is used to work together, they will create better musicals and will be more successful. And they created an index they call Q to see at that. And what they discovered actually is that if there is a small Q, so people is never worked together before, this is affecting the reviews of the musical. If the review grow when people start to work together a lot for more years, but then if they work too much together, so they get used to that, they don't think out of the box because they probably repeat what they did for the last 10 years, the review starts to go down and the revenue follow the same path. So we should think when we create a team that there should be some people that already work together and there should be some new people in every team. If we create always the same team, it will never work. That's why in Amazon we use the 2 pizza teams. And they are small because the communication path in a team, they grow with the square of the number of the participants. So if you have 3 people, they have 3 communication paths. If you have 5 people in a team, you have 10 communication paths. If you have 10 people in a team, you have 45 communication paths, and you will automatically create subgroups. So how can you create a good development team and be agile? Maximize the abilities, looking for diversity. Mix new and existing relationships, like we saw before, so that people has something new and something old to bring to the table, and minimize the number of communication paths. So probably 5, 7 people is the maximum size of a successful team. And to go beyond that, I listened to, this is the CEO of Zappos. He's thinking about the theory of collisions. So have people meet together randomly. So if you have multiple teams, create an environment where they can share their thoughts in a cafeteria, in an environment, because that's really, really important. Finally, don't reinvent the wheel. We work with our customers to share their stories so that you can know what you can do. So this is Capital One. I worked with them at reInvent last year, and they use exactly what I described today. So they use AWS SAM. Previously, they were releasing once per week. Now they release 2-3 times per day. They use CodeDeploy with canary releases so that they can monitor the release with an alarm and roll back automatically. And they say that they, for example, get 30% more time now that they work with serverless and with this canary automatic release model. So it's like having 30% more people in your team. The Guardian, they use workflows with step functions to coordinate activities. And the idea is that developers, they work on small topics, and then they merge the work of different working teams using workflows so that they don't need to create collaboration among developers that maybe look after different services. And the financial engines, they replaced some server that this is a company doing calculating risks and doing portfolio management for financial products. They replaced their optimizer with Lambda functions. They forced their Lambda function to be stateless so that they could reuse the same Lambda functions for multiple environments, and they replaced, I think, something like 50 servers with 4 Lambda functions. So for them, it was much, much easier to manage, and of course, from a matter of cost. So those are some ideas that I used for this presentation. They're taken from books. And what I like is that from these 4 books that I used for this presentation, only one is actually related to IT. The other 3 come from completely different fields. So look for different things. This is something that, like a circle, where you need always to improve. And I think the best way to bring serverless to the next level is really to be always curious and learn new things. Thank you.